All right, so section 8.7, and we will come back to section 8.6 eventually, but skipping to 8.7 today. Our learning target is that we want to be able to factor specifically perfect. Let me grab a pen first. Specifically, perfect square trinomials and what we call the difference of, in the math book, they say the difference of two squares. I just call it the difference of squares. Okay, so we'll work on those terms later. Let's just focus on how do we use these shortcuts today. And there's a nice graphic up top there. We're just going to work on how to use it. I'm not taking questions right this second, so unless it's an emergency, hold off, okay? All right, so let's go ahead and jump to it then. So it just says, what is the factored form of x squared minus 12x plus 36? Now, I would hope that even without a formula, you guys could do that one. Okay, we're not gonna do it that way. We're gonna take the shortcut, but you guys should be able to look at that and know that what we're looking for is a combo that multiplies to 36, adds to negative 12, right? And so we're gonna get there another way though. All right. So if you look at basically, there's kind of two versions of the formula. If you look closely at them, they're darn near the exact same thing. Okay, the only difference is the sign in front of the middle term. One's a plus, one's a minus. Besides that, they're the exact same. Okay, so the way you decide kind of which one to use is you look at, is there a minus or a plus sign? Okay, on your what you're factoring, right? So this sign right here tells me to use the one with the minus sign in it, right? So we're using this formula right here, so our answer is going to factor out into that form. So it's going to be an a minus b squared. Okay, a minus b squared. Now, what's a, what's b? So a is always, no matter what formula we're using, it's the square root of the first term. All right, so a equals the square root of x squared, which is just x, okay? And then b is the square root of the last term, which is what? What's the square root of 36? You can just blurt it out. 6, right? So once you have a and b and you have your formula, then you just plug it in and you're done, okay? So if it's a minus b squared, we plug in our a and our b. We know that our answer is x minus 6 squared. Now, if you were thinking about working ahead of me on a, which I think some of you were, hopefully the combination you came up with was negative 6 and negative 6. So x minus 6 times x minus 6. All right. So let's do another one together, and I'll try to have you guys help me a little bit more on that one. All right, so first of all, which formula are we going to use? Is this an a plus b squared or an a minus b squared? Plus, very good. All right, so this plus sign right here tells us this is a plus b squared. All right, now I'm going to call on you for what's a and what's b. So can anybody tell me what a is for this particular expression? Keep thinking, keep thinking. Bless you. All right, Robert, we got a lively bunch today. What's a? P is exactly right. Yep, that's right. Yep, you got it. All right, so what is b? What's b? Yes, 3. So if if a is equal to p and b is equal to 3, we're plugging into a plus b squared. What's my final answer? Andrea? P plus 3 squared. That's right. Now, what part of this, when people get pretty good at this, what part of the formula do you think people forget, maybe? Yeah?
Probably the part where you have to decide plus or minus.
Well, that could be, but that's usually people get a handle on that. here's what I see people forget is they'll remember the whole thing. Is it plus? Is it minus? I know to take the square root of the first term, square root of the last term, and then they'll just say the answer is p plus 3. Okay, so they'll forget to put squared on there. So just be careful of that. That's just something I've seen in the past. Okay, so without me coaching you up at all, you try to answer C all the way to the end. Okay. So is it a plus b squared or a minus b squared? What's a, what's b? And then plug them in. Okay, and that's all you do. You can get pretty quick at these. These are pretty quick problems once you get it. That was quite possibly the most muted nose blow I've ever heard in my whole life, I think. How you doing back there, Peyton? Yeah. I know. You're just sitting and waiting. That's why the shortcut's nice. All right, who's got an answer for me? Just final answer. That's all I want. Zaylen?
A minus B.
That's the form, but what's the final answer, though? That's all right. Yeah, we are going to do an a minus b squared. Peyton, what's my final answer? X minus 7 squared. That's right. All right, so yeah, so Zaylen, you were thinking like the first step, yeah, it's a minus b squared, but then we got to come up with also a is going to be x, b is going to be 7, so these go pretty quick, okay? So the key is, though, for you to be able to do them that quick, you know, recognizing that this is a shortcut problem. We'll cross that bridge later. Right now we're just focused on, I'm going to give you a bunch of shortcut problems. We're going to learn how to do them, okay? Or use the shortcut. All right, so how would one of these look in a word problem? Okay, so if you look back at our 8.5 notes, we have a really similar one to this. So it says digital images are composed of thousands of tiny pixels rendered as squares. Suppose the area of a pixel is 4x squared plus 20x plus 25. What's the length of a pixel? So again, they're telling us the area. On our 8.5 notes, we just had to kind of traditionally factor. We actually don't know how to do that yet on this one. If you look at this one, it's different than all the other ones we factored because it starts with 4x squared. We'll learn how to factor that. We don't know yet. Okay. What is a key word you think hidden in here, hidden in the problem somewhere that tells me that this is a perfect square trinomial? Yeah.
I feel like her word is one side of the pixel because you can tell
that's going to tell you to factor. That's a good thing. But what do you think is a key word that tells you it's specifically a perfect square trinomial? What's a word in the prompt or even in the example description? Squares. Yeah. So it's you know, the other ones have just a rectangle. This one is specifically a perfect square, right? So that means that this side and this side are the same, right? So I would just highlight the word squares, and that lets you know this is a shortcut problem, okay? So that'd be a key thing on a test because you might not know that otherwise. And you could do it, but you got a higher likelihood of getting it right if you know it's a shortcut and you know how to do the shortcut, okay? So once we know that, is it an a plus b squared or an a minus b squared? Just say it. Plus. All right, so a plus b squared. All right, it's maybe a little bit tougher to come up with a and b here. Anybody think they could tell me what the square root of that term is? A couple of you? What you got, Kevin? 2x, very good. All right, and then B should be easier. What's B? Just blurt it out. 5. All right, so we got 2x, we've got 5. We plug it into our formula, and we get our final answer of 2x plus 5 squared. So that's what the area is equal to. If you had this on a test, I would say you did it right. Math XL would count this one as incorrect. Can anybody tell me why, based on the last sentence? What's the wording of the last sentence? Yeah.
What is the length of one side of the pixel?
So can anybody tell me what the length of just one side would be? So this is the area. So what would the length of one side be? I'll give you a hint. The answer looks almost identical to what we have there. Yeah. It's just 2x plus 5, right? So if that's my area, I know that means, side times side. So the length of a side is 2x plus 5 units. All right? So anyways, the big thing is that you're able to factor it, okay? So moving on, we've got one more type of shortcut problem today, and this is the easier one to use, or it's the easier one to identify, okay? I think it's easier to use too because there's only one formula, right? So if you look up here, there's only one version of the formula. We don't have to decide, is it a plus or a minus? There's always one of each. We still use the A and the B, but this time we have to write out two binomials. So it's always A plus B times A minus B. Looking at our three examples, what physically about our quadratics makes them easier to identify? What's different about these three examples than the other things we factored? Robert?
These ones are all minuses.
They're all minuses. What else? What else sticks out more than the rest of the examples we've done? Only two terms. That's right. We've done quadratic trinomials up to this point. These are quadratic binomials. So you see this, it's pretty much always going to be what we call a difference of squares, difference of two perfect squares. All right. And again, you shouldn't know this yet, but the formula is always going to be this. Okay. It's always going to be A plus B times A minus B. Finding A and B is the exact same thing. It's the square root of the first term, square root of the last term. So A on this one is the square root of z squared, which is just z. B on this one is the square root of the last term, which is 3. Then we just plug it in. So our final answer, z plus 3 times z minus 3. No, you don't. The other one, we square it. Think about all of our answers kind of in the chapter so far. It's been binomial times binomial, right? So if I look back at our other one, I could write this answer as 2x plus 5 squared, or 2x plus 5 times 2x plus 5. So even though I put an exponent on there, it's really just two binomials. That's really just saving me some writing. Okay? Does that make sense? All right. Good question, though. All right, so let's do B more together. All right. So we know what our formula is. There's only one formula. So let's just think about what A and B are. Wilkerson, what's A? What's my A term going to be? A is equal to V. And Cameron, what's my B term? Grant, help her out. What's B equal to? Jalen, help him out. Andrea? How'd you come up with 10, Andrea? Seems to be baffling some of our folks. The square root of 100. That's right. Just like it has been on every other example. Feel free to join us, folks. All right. So we get v plus 10 times v minus 10. I think I just found the answer to why we can't give a 25 question test anymore. Just kidding, guys. All right. So go ahead and try that last one on your own. 100%, no coaching. It's going to be something plus something minus or times something minus something. And the somethings are the same in both. And if you get it, you're done. You're done and you're sitting, right? If not, talk to somebody around. All right, Sergeant Beaucamp, I'm coming to you on this one. It is exactly that. S plus 4 times S minus 4 is correct. And that's it, right? One last just side note that has nothing to do really with math, just kind of a little thing. Z's and S's as variables, you just have to be careful with them. When I make Z's in real life, I don't put that little mark through it. It just makes it not look like a 2. S's kind of look like a 5, so just be careful if you get some letters that happen to look like numbers. We are going to hold off on example 4 until Monday, and then Monday we'll finish that and then have some work time. Plus, you guys are going to have some work time right now. So take a break. If Lily has to listen to one more second, I think she's going to fall out of her desk. So everybody stand up and move around for a minute. Come on, people. It's Friday. Get happy. Even if you're in math class. I know that's a weird idea, but